Ever wondered what it takes to soar through the skies at unimaginable speeds? Imagine a beast of a plane that screams power and innovation. With its sleek design and impressive speed, this aircraft was truly ahead of its time. I mean, yes, we're talking about a plane that could fly at Mach 3. That's right, 3 times the speed of sound. It's like something out of a sci-fi movie, but this little boy was the real deal. Well, aviators, let's dive into the fascinating history of this strange superplane. With research and development studies beginning in 1955, the XB-70 was a large, long-range strategic bomber planned to be the replacement for the B-52. As in the B-58 program, the Air Force wanted new technology advances. To this end, the Air Force gave the prime contractor total weapons system responsibility. Competition between Boeing and North American for the contract occurred during the design phase. In 1958, the North American design was chosen and a development contract awarded. The Air Force requirement was for a Mach 3 high-altitude, long-range bomber capable of carrying nuclear and conventional weapons. Although there was a technology breakthrough in 1957 that made Mach 3 possible, the XB-70 never went into production. The continuing emergence of new SAMs was the key factor in the demise of the XB-70, just as it affected the B-47 and B-58. The XB-70 had a length of 196 feet, a height at the tail of 31 feet, and an estimated maximum gross weight of 521,000 pounds. It had a crew of 4, pilot, co-pilot, bombardier, and defensive systems operator. The Delta wing had a span of 105 feet with 6 turbojet engines side by side in a large pod underneath the fuselage. The wing was swept at about 65.5 degrees, and the wingtips were folded down hydraulically 25 to 65 degrees to improve stability at the aircraft's supersonic speeds of up to Mach 3. At this speed, the Valkyrie was designed to ride its own shockwave. A large canard foreplane near the front of the fuselage with a span of 28 feet 10 inches was used for stability. In addition to its sharply swept delta wings, the XB-70s had 2 large vertical tails. The aircraft was fabricated using titanium and brazed stainless steel materials to withstand the heating during the sustained high Mach number portions of the flights. The propulsion system consisted of 6 General Electric turbojet engines J93 GE3 with 2 large rectangular inlet ducts providing 2-dimensional airflow. The entire mission was to be flown at Mach 3, but even then the aircraft was vulnerable to SAMs of the 1960s vintage. A high-altitude Mach 3 penetrator cannot maneuver well. Its straight and level trajectory would have been an easy course to plot and intercept. Further, the technology that made Mach 3 possible yielded an airframe with a large RCS that added to the effectiveness of SAMs against the XB-70. The airframe was not adaptable to low-level penetration to avoid SAMs because the delta wings were very thin and did not lend themselves to the structural modifications necessary for sustained low-level flight. The XB-70 design had payload flexibility but not mission flexibility. In 1959, the XB-70 concept was changed to a Recon Strike RS-70, making it a reconnaissance aircraft with a bomber strike capability. However, its reconnaissance capability would not have been as good as the super high-altitude aircraft designed to fill the reconnaissance role. The XB-70 was an aircraft which fulfilled the criteria it was designed to meet, but whose mission had been eliminated by defensive threat technology. The high drag of the Mach 3 airframe required a fuel load comparable to the B-52 but limited the range to about 5,000 nautical miles. It was capable of carrying both conventional and nuclear weapons internally, but due to its design and Mach 3 mission profile, it could not carry external ordnance. In 1961, President Kennedy announced that the XB-70 program was to be reduced to research only, citing high cost, over $700 million per prototype, and vulnerability. The Kennedy administration felt ICBMs were more cost-effective because they were less vulnerable and were cheaper operationally. Although 2 XB-70 prototypes were built with the first flight in 1964, the program terminated in 1969. The XB-70 had speed, range, and adequate payload, but it was expensive, not suited to low-level penetration, and thus did not compete with ICBMs for strategic funds. During the early 1960s, the NASA Flight Research Center was involved in support of the National Supersonic Transport, or SST, program. Two prototype Mach 3 Plus high-altitude bombers built by North American Aviation for the Air Force became available for SST research with the cancellation of their intended military program. Aircraft number 2, with its improved wing design, was capable of sustained Mach 3 flight at altitudes around 70,000 feet. This plan went awry on June 8, 1966, when the second XB-70 crashed following a mid-air collision with NASA's F-104N chase plane. Joe Walker, F-104N pilot, died in the accident. North American test pilot Al White ejected from the XB-70 in his escape capsule, but received serious injuries in the process. Co-pilot Major Carl Cross, who was making his first flight in the XB-70, was unable to eject and died in the crash. The deaths of Walker and Cross and the destruction of the second XB-70 had major consequences for the research program. The second XB-70 had been selected for the Phase 2 tests, which were to be conducted jointly by NASA and the Air Force. With this aircraft now destroyed, only the first aircraft was available. Given the aircraft's shortcomings, the Air Force began to doubt that it would be able to meet the Phase 2 test goals. The first XB-70 was undergoing maintenance and modifications at the time of the accident to its sister ship. It did not fly again until November 3, 1966. Colonel Joe Cotton piloted it, while NASA research pilot Fitzhugh Fulton served as co-pilot. The flight reached a top speed of Mach 2.1. Between November 1966 and the end of January 1967, a total of 11 joint Air Force missions occurred. Cotton, Fulton, and Van H. Shepard of North American Aviation were crewmen on these flights. A top speed of Mach 2.57 was the highest attained during the remainder of the XB-70 program. These flights were made as part of the National Sonic Boom program. The XB-70 flew at differing altitudes, Mach numbers, and weights over an instrumented test range at Edwards. The boom carpet area was determined and the overpressure measured on two specially constructed housing units. Following these tests, the XB-70 was grounded for maintenance that lasted 2.5 months. The Air Force had concluded by that point that the XB-70 program should be turned over to NASA as soon as possible. The first NASA XB-70 flight occurred on April 25, 1967 by Fulton and Cotton. By the end of March 1968, another 12 research flights had been completed. The flights acquired data to correlate with an Ames ground-based SST simulator and the Jetstar in-flight SST simulator at FRC. The XB-70 underwent modifications after a final flight on March 21, 1968. During research flights, the XB-70 pilots had frequently experienced trim changes and buffeting during high-speed, high-altitude flights. These resulted from clear air turbulence and rapidly changing atmospheric temperatures. When XB-70 research flights resumed on June 11, 1968, the ILAF proved its ability to reduce the effects of turbulence and atmospheric temperature changes. The final XB-70 research flight occurred on February 4, 1969. Fulton and Sturmthal made a subsonic structural dynamics test and ferry flight. The XB-70 took off from Edwards and flew to Wright-Patterson Air Force Base, Ohio, where the aircraft was put on display at the Air Force Museum. The first XB-70 made 83 flights totaling 160 hours and 16 minutes, while the second XB-70 logged 46 flights in its brief life, totaling 92 hours and 22 minutes. So if you are fascinated by the aviation history of the XB-70 Valkyrie, be sure to hit that like button and subscribe for more thrilling contents. Thanks for joining me on this adventure. See you in the next video. Bye.